Well, the good news is this is the bad news we will read about for now, and we'll move on to looking at what are all the things we can do to solve this thing called climate change that was happening naturally anyway, and we came along and started tinkering with it and accelerating it and making worse for ourselves and for many other species and so on. But you can follow up on this by looking more specifically at what may be happening because of climate change where you live, because the books that I take, they are written somewhere by some author, and we keep taking them and making stories out of them or making podcasts out of them. But maybe it's not very specific to where you come from. Vegetation may be different, creepy critters may be different, plants and agriculture, humans, mountain, ocean, everything can be different. So you can begin to look around and ask everybody what's happening here. If you ask grandpa and grandma, they may be able to tell you, oh, in my old days it used to be like this and it used to be like that and now it ain't like that anymore. That's my imitation of grandpa, even though I'm a grandpa myself. So ask around. Okay, so let's look at colorless coral. You probably have a few shells lying around from some vacation or the other. If not, don't worry about it. If you are not too attached to them, you can use these for a simple experiment. You may have collected them when you went to the beach with hard work and they are precious to you, but take one and the least liked one that you have in your collection and see if you can do this. But be careful, whenever you do these things you have to have adult supervision. Pour some vinegar into a glass and add the shells. Top the vinegar after a day, so you add a bit more, and then for a few more days keep doing that. If the experiment works, there won't be much left of the shells after a few days. They don't like acid. Vinegar is acidic, that's why it tastes nasty, because the acid dissolves calcium carbonate. It's like Pepto-Bismol, if you know what that is, or some kind of a salty drink you can get in your city, or get a salt that you put into the water and fizzes and makes something that's supposed to make your stomach feel better if you're feeling gassy or acidity and so on and so forth, right? So acid dissolves calcium carbonate, and the shells are made of calcium carbonate. Not just the shells, but also the entire coral. There are lots of plankton, and the shells of crabs and lobsters are also made from calcium carbonate. Luckily, the oceans aren't made of vinegar, but as you have already read, they are becoming more acidic because of the emitted CO2 is ending up in the oceans. Otherwise, there could have been more CO2 in the air, so it's a good thing that the ocean takes out some and leaves less greenhouse gas in the atmosphere, so the warming is not as fast or as large as it could be. But CO2 does get up to no good in the ocean either. CO2 doesn't get up to much good in the oceans either. It dissolves into the water, forming substances including carbonic acid. H2O plus CO2 should give you H2CO3, which is carbonic acid. You know, the stuff that makes bubbles in your soda and makes you feel like it's yummy when it goes down, but mom will be telling you don't drink too much of that stuff, it's not good for your stomach. Since the Industrial Revolution, seawater has become 30% more acidic. Obviously, like the heat and the temperature, it's not everywhere, but if you take all the acidification everywhere together, it's 30% higher than before. You have seen what acid does to calcium carbonate with this little experiment. Poor shells, corals, planktons, crabs and lobsters. Poor marine life, in fact, because all life in the seas depends on phytoplankton and other small animals and the plants, and in turn lots and lots of people are dependent on fish and other sea creatures, and people love lobsters and they like a good crab meal. In Maryland you get this blue crab, in Maine you get this lobster. People go to Hawaii and bring live lobster frozen in the airplane all the way to their house because it can stay alive for a long time in a frozen condition. Oceans all over the world are suffering because of this, but you hear most about Australia's Great Barrier Reef. Just off of Australia in the northeastern part, you have the Great Barrier Reef that we said is 2600 kilometers long, if I remember right. That makes sense because it's very big and very beautiful. That's why it's called the Great Barrier Reef, and it's a very important place for so many animals and plants, but it's also having a very hard time. This is not only because of acidification, when coral organisms die, their calcium carbonate skeletons remain behind on the top of the rest of the coral reef. So the reef is actually a huge pile of skeletons that you can see here. When it's nice and colorful, there is some symbiotic algae growing on it. What is symbiosis? If you don't know, you read up. It's basically where the coral allows the plankton to stay on it, and the plankton does something for the coral. It photosynthesizes and takes out the CO2 and produces oxygen so the coral can breathe, and then the phytoplankton photosynthesizes and attracts zooplankton and other fish, and soon the coral is like a rainforest in the ocean full of life. Nutrients are being circulated and recycled, and oxygen is being recycled, CO2 is being recycled, coral is happy, the fish are dancing around happily, and they are very colorful. The tropical fish are very colorful to match the colors of the corals, and they attract mates with their colors and make very good places to go looking at corals and not destroying them, kids, right? So that's what you have to remember. Okay, so this is not only because of acidification. Corals are a pile of skeleton. The living coral organisms are on top of the reef. They have a good deal with the algae that grow on them. The algae get CO2 from the coral and transform that by photosynthesis into food and oxygen for the coral. So everyone is happy, but algae are rather sensitive types. Like the coral, they can't handle acidification or temperature changes very well, and they certainly don't like warm water. If the waters warm up by just 2 degrees, the algae become poisonous. They turn on you. The coral senses this and says so long, and basically gets rid of the algae. Basically it rejects the algae. That's when you realize that the coral's beautiful colors were only there because of the algae. Without the algae, the coral looks pretty pale, like a chalk calcium carbonate, just plain white. So it's not very healthy, not a very healthy situation. The coral will keep going without algae for a while, but if the water doesn't cool down fairly quickly, the algae will not return, and the coral is at risk of dying because the coral needs the algae for its food and oxygen. Now that the oceans are becoming warmer and warmer, this is a serious danger for the Great Barrier Reef and the other corals in the world. If this bleaching is called bleaching because from a colorful coral it goes to looking pale white, and all these fish are looking at the pale white coral and saying, uh-oh, you don't have any food for us, bye bye. They will try to go somewhere else. If this bleaching continues, it's very bad news for divers, snorkelers, fishes, and above all for the millions of animals and plants that live there. One thing we haven't talked about is when plants and animals live there, what are they doing? They are also consuming some carbon, and when they die and sink to the bottom, they are taking out some carbon as well. This is the carbon cycle we talked about in another section before. Life is part of the carbon cycle, and naturally the carbon should be going out and coming back in and so on, but we keep adding and adding and adding. So meanwhile, cephalopods, This includes animals such as the squid and the octopus. That's the biological name, cephalopod. They are rubbing their tentacles together all over the world, like we wring our hands when we are in trouble. We say, oh my god, what's happening? So cephalopods are wringing their hands together all over the world. Things are going well for nearly every species of cephalopod. This is no doubt connected to the fact that many of their natural enemies are being fished out of the sea. Now we are adding something else. Human beings are affecting the ecosystem. If there is a cephalopod running around hiding from the predator, and the human being comes and takes the predator and says, you are a yummy meal for me this afternoon on the barbecue grill, and the cephalopod looks up and says, thank you human, now I have nobody to eat me. So they are not rubbing their tentacles always because of the warming and acidification. Sometimes they are rubbing their tentacles together saying, now there is nobody to eat me, and then they sing a Disney song and dance at the bottom of the ocean. This is no doubt connected to the fact that many of their natural enemies are being fished out of the sea. The cephalopods don't mind that at all, but their good fortune probably also has to do with climate change. Cephalopods can quickly adapt to new circumstances, and they are not too fussy about what they eat. They are often filter feeders. They just take in the water and take out whatever particles there are that have some nutrition in them. So if a coral reef dies off somewhere or a food chain disappears, they're only too happy to hurry over there and fill the gap and take over the new real estate, saying, this is now my neighborhood, go away. So biology always responds, and we said nature makes the rules and biology finds the loopholes, and this is what we mean, that if the coral dies because of the warming and the acidification, then maybe the cephalopods come in, or there are other things like the jellyfish, which also can live happily in waters that are not full of fish and phytoplankton, and they can eat whatever little food there is. And the jellyfish can get bigger and bigger, and off the coast of Oregon in the Pacific Ocean or in the Sea of Japan, sometimes they have jellyfish as big as cars. And some jellyfish are eaten, but you cannot eat so much jellyfish. So when a lot of jellyfish come, it probably means bad news for the fish, and some of the jellyfish sting. So if you're happily sailing around and want to jump into the ocean and swim around, there are a lot of jellyfish, you are going to be crying because the jellyfish are going to sting you. So you see how many things we are doing, not only to ourselves, or not only to the atmosphere and the ocean, but all the plants, all the animals, all the fish, all the mammals, polar bears, and so on and so forth. So this chapter of bad news is finished, and we'll come back and look at hydrogen. What will we do with hydrogen? Is it energy? Is it renewable energy? And we'll talk about insect burgers. I mentioned dipping that processional caterpillary thing, whatever it was called, I already forgot. You should go back and see. Let's not be lazy. Let's go and see what we called it. What did we call it? The oak. No, that's not the. Yeah, that's the oak processionary caterpillar, right? So we will be dipping them in chocolate and eating them, so we'll talk about that in the next chapter. Don't get freaked out, don't get creeped out. Come back and listen. It's fun and it's a solution to climate change. Children, come back, come back, come back.